Okay, in this video we're going to look at one of my favorite tests and one of the most important convergence tests there is, the ratio test. First of all, I would like you to go and answer these three questions on Schoology. This is the quiz for this video. Just to say if it converges or diverges, let me give you a couple quick hints. When we're looking at things like this that are polynomial on top and bottom, not a bad idea to think about using the limit comparison test. It would work pretty well. You know, what you'd compare to, I usually look at kind of the biggest stuff and say, well, what about like 3 over n squared? Okay. For the second one, it's really hard to compare things when it's not expanded. So maybe begin by expanding this, and then maybe start thinking limit comparison again. And if you need to look back at what it takes to converge, you sure can. And on this final question, you'll notice that we've got a integral going from 1 to infinity, so it's obviously improper with an infinite bound. So, maybe set it up that you're going to have the limit as b goes to infinity, right, from 1 to b. Okay. Now, what I would look at with this would be, because it's a fraction, I wouldn't use integration by parts. Not really factorable, so I would maybe look to use substitution. Maybe think about making u equal to 1 plus x squared. So du would be 2x dx. So dividing by 2 maybe takes this out. Okay, and then do the integral that way. So again, pause here, or solve those. For 1 and 2, you'll just be answering C or D, converge or diverge. And for number 3, of course, you'll be giving the answer to that question from an old AP exam. Now, the ratio test is one of the most useful and most common tests to need because it's going to help us a little bit down the road doing what's called the radius and interval of convergence. But the idea is very simple. The idea is that I'm going to set up a ratio between the next term in my series and the current term in my series. And if I can show that the next term is always going to be smaller than this term, then I can show that the series converges. If, on the other hand, I show that the next term will be larger than the current term, I show that it diverges. Unfortunately, you'll see this ratio that, if the next term divided by the current term is less than 1, meaning the current term is larger, it converges. If the next term divided by this term is larger than 1, meaning this current term is smaller than the next term, it diverges. If it's equal to 1, there's nothing we can do. Okay, there's nothing we can do if it's equal to 1 except move on to a different test. Okay, so maybe you want to make that note. I know it is on your sheet of convergence tests, but if the ratio comes out to be equal to 1, this test doesn't work. This really works well for factorials. Okay, with a little bit of algebra, it works great for factorials and for exponentials. Okay. That's what this test is so useful for. So take this first one. We're doing the we're doing the series from n equals 1 to infinity of 1 over n factorial. So I'm going to write this as a limit. The limit as n approaches infinity. Okay. I'm going to do the next term. Well, the next term would be 1 over n plus 1 factorial. Okay, if the general term is just 1 over n factorial, the next term in the sequence would just be 1 over n plus 1 factorial. Essentially, you're replacing every n with an n plus 1. and then I'm going to divide by the current term, just 1 over n factorial. Well, dividing fractions is the same as multiplying by the reciprocal. So I'm going to multiply by n factorial over 1. Now, we don't do enough algebra with factorials, I don't think. So I just want you to think about this. And let me maybe just write it kind of right over here. N factorial is n multiplied by n minus 1, multiplied by n minus 2, and on all the way to 1. Well, n plus 1 factorial would be n plus 1 multiplied by n, multiplied by n minus 1, multiplied by n minus 2, and so on down to 1. So you'll notice that a lot of this stuff divides out. So what I'm going to be left with is a 1 on top and an n plus 1 on the bottom. Well, the limit of that as n goes to infinity is 0, because the higher power is on the bottom. So I now know, because 0 is less than 1, I now know that this converges. Okay. Next. Let's do the same thing again. I think it works best for factorials and exponentials. You see, in this case, we have both. So here we've got a limit as n goes to infinity. Next term would be n plus 1 raised to the n plus 1 over n plus 1 factorial. Now, in the interest of space, I'd be dividing by this fraction. I'll write that out. I'd be dividing by n to the n over n factorial. Let me just kind of zoom this up and say, okay, we're multiplying by the reciprocal, right? Like that. So once again, kind of similar to the previous problem, the n factorial and the n plus 1 factorial, this is going to cancel completely, and the factorial is going to disappear. So let me kind of work this. Leave me a little room here to write my limit statement. But I'm going to have an n plus 1 in the denominator. Okay. Now, the rest of this is a little bit tricky to look at algebraically, but I want you to think about this, okay? We've got this left, so I'm just going to write, we've got an n plus 1 to the n plus 1. And on the denominator, we've got an n to the n. So let me put this in parentheses so I can write n to the n. Now I want you to focus on the n plus 1s for a second. N plus 1 divided, or raised to the n plus 1 divided by n plus 1. Well, this cancels with one of these. Okay, make sure you see that n plus 1 raised to the n plus 1 divided by n plus 1 divides one of the n plus 1s away. So now I've got the limit as n goes to infinity of n plus 1 to the n over n to the n. Okay, which is a geometric sequence, really. If you think about it, it's geometric now, and the top is bigger, so this will diverge. Okay, I don't have a lot of room here. Okay, now that's a pretty tough ratio type question, but what it comes down to is the fact that because the top is bigger, they're both being raised to the nth power, and the top is bigger. Let's do one more that's not quite as difficult as that previous one was, because that's kind of a monster to do with ratio test, okay? Again, we're looking for exponents and factorials, so this is a perfect time to set this up. So we're going to do the limit as n approaches infinity. Again, the next term divided by the current term. Okay, dividing fractions, let's just flip it. That. Okay. So what we see here, and the beauty of this, and what I love about this test, is we've always got to do a little algebra. So I'm going to leave the n plus 1 over n. Okay, this stuff, not much I can do with that. But 2 to the n plus 1, 2 to the n divided by 2 to the n plus 1, well, this completely divides out with these. You've got 2 to the n divided by 2 to the n plus 1. So what we have is a 2 on the left on the bottom, a 2 and an n, and on the top we have an n plus 1. We're doing the limit as n approaches infinity. Well, again, we have the same power on top and bottom. So the limit is 1/2. That's less than 1. So this converges. Okay, so just kind of backtracking through the ratio test here. What you always do is, first of all, identify it with, if it's using factorials or exponents, that's a great chance to use it because the algebra is so solid and things will cancel out so quickly. That's why it's such a great test. But the idea is simply that we're trying to show that the next term will be less than the current term, that it is always getting smaller. On the other hand, if we prove that each term is getting successively bigger, we can prove divergence. If the ratio comes out to be 1, we've got to pick another test. But what we have here is we always put an n plus 1 in place of every n because this represents the next term. We divide by the current term, which looks exactly like the series, as a sequence defined. We do the algebra. In this case, 2 to the n divided by 2 to the n plus 1 just left a 2. I left the n plus 1 and n, and then we say, well, n plus 1 divided by 2n, that has a limit of 1/2, using kind of our old pre-calculus rules. And if you wanted to use L'Hopital, you could, because it's infinity over infinity. Do the derivative of the top and bottom, you're going to get the same thing. Okay, so that's the ratio test.